Since I'm attempting to film in my house today, you may hear some background noise, and I thought I would introduce you to the source of the majority of the background noise. That's Joy. She's 18, and she is a little on the noisy side, right? Joy apologizes for any interruptions. This is the other source of noise, and I'm sure she's also, well, no, she's entirely unapologetic, right? Friday, speak. Speak. Yeah, that's right. Future Amanda here. I just wanted to draw your attention to the nets in the back of your textbook. They're on perforated pages. I've taken mine out. And I wanted to show you a couple of things I think are kind of nice. First of all, you can make better nets than this. Sometimes they will have little tabs here, and then you can use glue or double-sided tape on those tabs to attach them rather than having to use tape on the outside, and you get a better and a stronger result. But nets are a fun activity to do with your class, and this was actually something I had planned to do in a class activity with you guys. So you'll notice I've got some tabs here, and what I'm doing is I'm marking the regular polyhedra. Now, regular polyhedra are the ones that use the same shape for every side. And in fact, these have something more in common, which is that they have the same number that meet at each vertex point. So there is a surprisingly limited number of polyhedra that meet those conditions. And they're typically called platonic solids because they were discussed a lot by Plato. So this one here is a tetrahedron, it's called, also sometimes called a triangular prism or a triangular pyramid, because it's a pyramid with a triangular base. There's no regular one on this page, although it's interesting to think about what shapes these might make. So for example, you can see that this has a square base, but different sizes of triangles for the sides that will meet up in a point that's sort of off center. Here's another regular polyhedron. This one is a square. This one is a pyramid with a a pentagon for a base. More potentially interesting shapes. This is kind of like a rectangular three-dimensional shape, except the top is going to be smaller than the bottom. Here's a regular polyhedron, also a platonic solid. So this makes a shape called a dodecahedron. Dodeca meaning 12. This has 12 sides, each of which is a pentagon. This one has the largest number of sides of any of the platonic solids. It's called an icosahedron. It has 20 sides, all of which are triangles, equilateral triangles. And this last page, first of all, down here, this is the last of the platonic solids, the last of the regular polyhedra with the same number of faces meeting at each point. And this is an octagon. So that has 8 sides, also all equilateral triangles. So of the 5 platonic solids, 3 of them are made with triangles, equilateral triangles as sides. Also interesting to look at these two and see if you can predict ahead of time what you think those would be made up. I found this one a little easier. That's going to be, well, I'll give you a second to think about it, actually. I'm going to try to make these later if I have time, and then you can see my examples. So this would be a cylinder. And this one took me a minute to figure out, but I realized that when you wrap this up, you're going to get a cone shape. So this is going to give you a cone with the same base as this cylinder. So these are the results once I made up some of those nets from the back of the book. Mostly I focused on the 5 platonic solids here. I just made a couple others up that I was curious about. I wanted to see what they looked like. This one because I couldn't figure out what it was going to look like when it was made up. It's net J, in case you're interested in looking. But these, I have, let's see, going up in size, number of sides, I have a tetrahedron, a cube, an octahedron, a dodecahedron, and an icosahedron. So we have 4, 6, 8, 12, and 20 sides. There are actually some really interesting patterns about the number of faces and the number of edges that maybe you'll get a chance to develop in another math class someday. But I wanted to point out 3 of these are made from equilateral triangles. One is made from square, one is made from pentagon, and those are your only options for regular platonic solids, meaning they have the same, each side has the same shape and the same number of sides meet at each corner.